Okay, hey guys, how you doing? We're gonna get started on some new material. I want you to take a look at this either today, over the weekend, on Monday, whenever. And on Monday, I will give you some things to to check your knowledge and see how you're doing with this, and some practice games. Hopefully, they work on quizzes. I found 3 pretty good ones that you know you can compete against each other if you get on at the same time. So, but anyway, we're going to be in chapter 7. We multiplied things like 6x squared times 3x to the 4th, and we ended up with like 18x to the 6th, right? You guys remember that? Okay. We're going to do more of this type of thing in this chapter, but they're going to be larger polynomials. These are all just monomials here that we multiplied. And so we're going to be working with polynomials, which is, 2 terms or 3 terms. And the first thing we're going to do, though, is we're going to learn how to subtract and add them together instead of multiplying. We're going to do that later because we need to figure out what our like terms are first, okay? All right, now on the page here, the vocabulary, we're going to skip most of this because it's not really that important. But a binomial just means 2 terms. So like 2x plus 6, those are 2 different terms. And we'll explain more about that in a minute here. Or you could have like 4x squared plus 3x plus 5. That would be 3 terms, right? Okay. A monomial would just be like 6 or 5x or something like that. Okay. And all of these could be called polynomials. All right. Now, the standard form of a polynomial, we're not going to worry about degree right now. The standard form is just the correct order. And you notice it's descending. That means it goes largest exponent to smallest exponent. So if I had like x cubed plus x squared plus 2x minus 4, that would be in standard form, or the correct order, descending order, okay? And this last term here, the leading coefficient of this guy, that would be 1, because there's a 1 in front here. The leading coefficient of this is 4. Okay, it's the first term. When it's in the right order, when it's in descending order, the leading coefficient is the first coefficient, the first number there. Okay? All right, the other term that's not on here that we really need to talk about is called like terms. Okay? So, like terms have the same variable and the same exponent. Okay, that's very important. It's going to come into play later on when we get into multiplying and what we're doing right now. But I mean, it's going to be really important when we try to multiply things that we realize we have to put like terms together. So these 2 terms are not like terms, right? But what if I had this? Are those like terms? Yes, they are, because they have the same variable and the same exponent. And so I can add those together to make 8x. These 2 I can't put together. I have to leave them separately with that plus sign in between there. Okay, so what about this? What if I have 3x plus 4y? Not like terms, are they? Because they're not the same variable. Okay, so I have to leave them separately like this. All right, so here's some not and some like. So if I had like x plus 4, or if I had 2x minus 6x, that would be negative 4x, right? I can put them together. Or if I had 3x minus 4y, what if I had 3xy plus 4xy? Are those the same? Yes. Okay, what if I had 3x squared plus 6x? No. Not the same exponent. But if I had 4x squared plus 7x squared, yeah, I can put those together to get 11x squared. So I can always add or subtract like terms. They have to have the same variable and the same exponent. Okay? And we'll talk more about that as we go through here. All right, so this first slide here, again, remember the the formatting didn't work very well, so I'm rewriting this thing. And they just want you to put it in standard form, which is descending order. And so you can see they've done that down here. The 3x to the 6 should come first, and then the x squared, and then the x term. And the leading coefficient is 3. So those are things that we talked about earlier when we did the vocabulary before. Okay, so not a huge deal there. Just put it in the right order. So the biggest exponent goes first, so 3x to the 6th, and then the 9x squared, and then that 4x. Make sure you keep your signs the correct signs, you know, pluses and minuses. Okay, the only minus we had was the 4x, and he didn't even really move, so a big deal. So on this one here, I'm going to rewrite it for you here. 34x plus 9x to the 4th plus 3x to the 7th minus 4x squared. So our biggest exponent is 3x to the 7th. Our next biggest exponent is x to the 4th. And then we have a 4x squared. And then we have a negative 34x. Notice I kept all the signs together with their, you know, their term. Each term has the correct sign that it had at the beginning. Okay? But I start with the biggest exponent, the next biggest exponent, and so on. And then my leading coefficient would be 3. Does that make sense? I hope. Let me know if you have questions. Okay? All right, now we're going to start putting this stuff together. Okay, we're going to start combining our like terms because we're going to be adding two polynomials together. Okay, so we've got 7y squared plus 2y minus 3 and plus 2 minus 4y plus 5y squared. Okay, the order here, they don't have it in the right order. It doesn't really matter that much for us right now because, you know, we're just going to put our like terms together. So these two guys are the same, aren't they? They're like terms. And since they're both positive, I'm going to add them together to get 12y squared. These two guys are also like terms because they just have a y and they're to the first power. So now I have a positive 2y and a negative 4y would give me a negative 2y. And then I have a negative 3 and a positive 2. Well, negative 3 plus 2 is negative 1. And look, that's what they got. Wowzers, we did it right the very first time. All right. So all I'm really going to be doing is just combining like terms. They have to be like terms to be able to do that. All right, so here we got the same kind of thing. I got 4x squared minus 2x plus 7. And then in parentheses, and then I got 3x minus 7x squared minus 9. So again, these two will go together because they are like terms. So that's going to end up being a negative 3x squared. And then I've got a negative 2x and a positive 3x, so that's going to be a 1x. I could put a 1 there if I wanted to. And then I have a 7 and a negative 9. I have to keep track of those signs. That's going to give me a negative 2. All right. All right. Now here's another example for you. You can, the answer's there, see if you can get that. But if I put these two together, that's going to give me a negative 2x squared. If I put these two together, it's going to give me this 5x, and it's positive. And then these two are going to give me that positive 3. All right. I'll let you guys try this one on your own. You can do whatever you like. I'm going to write it so that there's less confusion about what the exponents are. Okay. All right, now, this is where it can get a little bit hairy because of this negative sign right here. We're still going to do the same thing. We're still just going to combine like terms, but the problem comes in is keeping the signs on this side straight. Because if you think about it, if I took a negative 2 times 3x minus 4, doesn't that change the signs? When we distribute that through there, that's going to become a negative 6x and a positive 8. That negative changed the signs inside, didn't it? So this negative is going to do the same thing. It's like a negative 1 out here. So in my book, I'm going to rewrite this down here. And notice they're not in order, and that's okay. We're going to put ours in order, but we're not worried about theirs just yet, because I don't want to write too many things down before I even get started. All right, so what I would do, my first step would be to change this negative to a positive. But then I have to change all these signs. So watch this. I'm going to go 6y squared plus 8y to the fourth minus 5y, and then I'm going to say plus, and then I'm just going to change every single sign. So 9y to the fourth plus 7y and minus 2y squared. So now it's exactly like what we were doing before. All I did was change the signs in the second one. I did not change the first. No change in the first guy. Only the one that we're subtracting. This guy changes. Okay, so now we just look at our like terms. I got an 8y to the fourth and a negative 9y to the fourth. So that's going to be a negative 1y to the fourth or negative y to the fourth, which is what they have right there. Then the next term, I got a 6y squared here. Do I have any y squareds over here? Yep. I got a negative 2y. So 6 minus 2 is going to be 4, positive 4y squared. And then I got a negative 5y and a positive 7y is positive 2y. Notice I wrote it in descending order. I wrote my answer in descending order there. Okay, biggest exponent, next biggest exponent, smallest exponent. And if there is no exponent, like if there was a 5, that would go on the end. Always put that guy on the end, okay? And notice that's what they got over here. So, we did it right. All right, so let's try this one here. Let's make sure we know what we're doing. I'm going to shrink this down. I'm going to go 6n squared plus 11n cubed plus 2n, and then minus 4n minus 3 plus 5n squared. So now, the first thing I'm going to do when I have that minus sign is I'm just going to change it to a positive and then go through and change every sign of every term that's in there. Okay, so now I'm adding two trinomials here, and I'm just going to put their like terms together. So first thing is, if you notice, the biggest exponent I have is an n cubed. Is there any n cubes over here? Nope. So we just write 11n cubed. It doesn't change. Now I got an n squared here. He's positive, and this guy, oh, he matches, is negative. So 6 minus 5 is 1, so I could just write n squared. And you'll notice that's what they have there so far. And then they've got this guy and this guy. They match, don't they? So positive 2 minus 4 would be negative 2n. And then you'll notice there's this guy here all by himself again, kind of like this guy was. So this 3, I just put him on the end. There's no 3, there's no constant over here. 3 is a constant because there's no variable on it. There's no other number over here to add to it, so I just leave it, just like I left the 11n cubed alone. Okay, does that make... Let me know if you have questions about this stuff. I'm going to give you a couple here to look at. I'm going to let you guys do this one on your own. Whoops, I don't want that. Click out of that. All right, here we go. 3x, come on. 3x cubed plus 2x squared minus x to the fourth. And then minus x squared plus 5x cubed minus 2x to the fourth. And remember, you change your sign and switch all the signs in this parenthesis. Okay? I'll let you work on that for a little bit. Then you can one, and I think it's B on that one. If I'm looking correctly, yeah, it looks like B for this next one here. So the same thing here. If you're having trouble, let me know. I will try to help you. I'm just writing these down so that you can see them a little bit better. Okay, so I do believe the answers here are correct. They circled D on this, so let me know if you have questions. This is just the first part. We're going to be using this to help us when we multiply, okay? After we get done multiplying, then we have to add stuff together, just like if you were multiplying numbers, okay? You know, if you had 24 times 12, well, you'd have to add, wouldn't you? You'd have 8 here and a 4, and then you'd leave a blank, and you got a 4 and a 2, and guess what? You got to add them up, don't you? Okay, so it's the same thing when we're multiplying polynomials. So we have to be able to add like terms together to be able to multiply polynomials successfully. So let me know if you have questions about this. Like I said, I will post a quick check on Monday and some practice games for you to look at, and then probably have them do like at the end of the day on Tuesday or something, and then on Wednesday we'll start multiplying. So let me know.